Hello, calculus students. In this problem, we're going to find the parameterization of a tangent line evaluated at the point indicated, and the point indicated here is t equals pi over 4. Okay, so here's our path, our vector valued function, and you may recall that the equation of the line is the path evaluated at the given point plus the parameterization, which is the t, times the direction vector, and since our direction is in the tangent direction, only makes sense that we would multiply that by r prime to t naught. Okay, I'm not sure if you recall that the equation of a line in general is given by this formula here, where this vector v is the direction vector. So the direction vector in this case is r primed. Okay, that's enough background. Can also get that out of your calculus text or your class notes, I'm sure. So t naught in this case is pi over 4. So let's first evaluate the path at pi over 4. There's our path, and then we'll evaluate r primed at pi over 4. So I'll take that derivative in a moment. So r at pi over 4 means I have to take the cosine of 2 times pi over 4, comma, sine of 3 times pi over 4 times sine of 4 times pi over 4. And I'm just going to quickly take care of that. So that's the cosine of pi over 2, because the 2 cancels with the 4 to give me a 2. And so I get a 0 in that location. And then I have a sine of 3 pi over 4. So that puts that in the second quadrant. And y is still positive. The y coordinate is still positive in the second quadrant, so the sine is positive in the second quadrant. So that's square root of 2 over 2. And these 4's cancel to give me a sine of pi. And everyone knows that the sine of pi is 0. So there's r of pi over 4. And that is going to be this point here. And so now I need r primed of t. So I'll compute that first, because I'm going to need a chain rule. Not the vector chain rule. I'm going to need a chain rule component-wise. Because remember, we take the derivative of a vector, vector value function, we take the derivative of each of the components. So let's go ahead and do that. So using the chain rule, the derivative of cosine 2t is minus 2 sine of 2t, comma. The derivative of sine 3t is 3 cosine of 3t. And the derivative of sine is 4 cosine of 4t. And all right, that takes care of the vector. So now let's evaluate that vector at pi over 4. Okay, so we'll just do that. So I have minus 2 sine of 2 times pi over 4, comma 3 cosine of 3 times pi over 4, comma 4 cosine of 4 times pi over 4. And then I'll simplify it just as I did in the previous step. So I'll have a sine of, let's see, the 2 cancels out with the 4, so I'll have a sine of pi over 2. And let's see, that will give us a minus 2 times the sine of pi over 2 is simply 1. Okay. Then, cosine of 3/4 pi, that puts us in the second quadrant. The x-coordinate, therefore the cosine is negative. So that will give us a negative 3/2 square root of 2. The 3 here coming from this coefficient. And then the cosine of 3/4 pi is negative square root of 2 over 2. And let's see the last one. The 4's canceled, so we have cosine of pi, which is a -1, and -1 times 4 gives us a -4. And so that is our direction vector in the tangent direction. So now we just simply have to apply this formula, and by evaluating it using these two vectors. And let's see if I can just squeeze that in down here. So I have L of t equals 0 square root of 2 over 2, comma 0, so that's the vector, plus t, and I could do a little bit of simplification here, minus 2 minus 3/2 square root of 2, comma minus 4. And that's the parameterization of the tangent line at pi over 4. Okay, good luck.